Hi guys, Andrea Spar here, and this is my presentation on generating acetyl-CoA from pyruvate, and the title is All Roads Lead to Rome. The Krebs cycle, also known as the citric acid cycle, starts with pyruvate, which is turned into acetyl-CoA. And I have a picture of the citric acid cycle and where pyruvate starts in the top left-hand side, and we'll go into further detail on the next few slides. Glycolysis. During glycolysis, glucose is partially oxidized in the cytoplasm. Small amounts of ATP produced during glycolysis. There are two pyruvate molecules that are formed by glycolysis. Pyruvate is then absorbed into the mitochondrion. Pyruvate is broken down into the mitochondrion in the presence of oxygen, and this is to produce carbon dioxide and water. And then large amounts of energy in the form of ATP is produced per glucose molecule. Also, glycolysis occurs in the cytoplasm of the cell and does not require oxygen. The breakdown. Pyruvate oxidation is a key connector that links glycolysis to the rest of the cellular respiration. After glycolysis, pyruvate is converted into acetyl-CoA in order to enter the citric acid cycle. Acetyl-CoA is a molecule that is further converted to oxaloacetate, which enters the citric acid cycle, which is also known as the Krebs cycle. The conversion of pyruvate to acetyl-CoA is a three-step process, and I have that in the photo here on the right, and we'll go into these in further detail. This is an image that I got out of the book on page 333, and it is showing that pyruvate produced by glycolysis is converted into acetyl-CoA and the fuel of the citric acid cycle. Fatty acid disintegration is also an important source of the acetyl-CoA for the citric acid cycle. And if you recall that glycolysis generates two molecules of pyruvate for each glycose molecule metabolized, this irreversible conversion of pyruvate into acetyl-CoA is the link between glycolysis and the entire citric acid cycle. Step 1. A carboxyl group is removed from pyruvate, releasing a molecule of CO2. The result of this step is two carbon hydroxyl groups bound to the enzyme pyruvate dehydrogenase. And I'll show you that to the right, how it's broken down. Step 2. The hydroxyethyl group is oxidized to an acetyl-CoA group, and the electrons are picked up by the NAD+, forming NADH. The high-energy electrons are then saved for later use to generate ATP for energy. Step 3. The enzyme-bound acetyl group is transferred to the CoA, producing a molecule of acetyl-CoA. This molecule of acetyl-CoA is then further converted to be used in the next pathway of metabolism, which is the citric acid cycle, or the Krebs cycle. And again, I have the photo broken down to the right. So here's another photo just showing where you're going to pyruvate, where transfers of protein, you pick up your CO2, NADA plus turns into NADAH plus a hydrogen plus, your coenzyme A, and then your result would be acetyl-CoA. Each pyruvate molecule loses a carbolic group in the form of CO2. The remaining two carbons are then transferred to the enzyme CoA to produce acetyl-CoA. Acetyl-CoA in the citric acid cycle, for each molecule of the acetyl-CoA that enters the citric acid cycle, two carbon dioxide molecules are released and removing the carbons from the acetyl group. The cycle can only restart once the dihydrolipomide and the oxidized back to the lipoamide, and this is catalyzed by the E3. So here I have the citric acid cycle, and I'm just going to run through what's going on here. You're going to start at the top. During the Krebs cycle, oxidative decarboxylation of the C2 acetyl group CH3CO occurs yielding ATP. Reduced coenzymes and CO2 is produced as a byproduct. Acetyl-CoA joins with the C4 receptor group, oxaloacetate. CoA is released to transport more pyruvate into the matrix. A C6 fragment citrate is formed. C6 citrate is oxidatively decarboxylated. A C5 group is formed. The carbon is given off as CO2. NADH plus is reduced to NADH plus H plus. The C5 fragment is oxidized and decarboxylated further to a C4 compound. Again, the carbon is removed, forms CO2. NADH plus is further reduced to NADH plus H plus, and the final stage in the cycle has the C4 acceptor regenerated. This is a reduction of the NAD plus to the NADH plus H plus. FAD which is the coenzyme, is reduced to FADH2, and ADP is reduced to ATP. And here I have it laid out again. It's just another steps of the citric acid cycle. There are 8 steps. Your black are your substrates, blue are your steps, green are your inputs, purple are the controlling enzymes, and red are the outputs. And anytime you see a star, that is your energy that you are getting. I want to thank you all for looking through my presentation and listening to me babble on. And I'm just one of those people that like to add a funny at the end of most of my PowerPoint. So here you go. If all roads lead to Rome, where do the roads in Rome lead to?